have heard it before. And he was a Russian guy that basically said he was mad at the world, and he was like, I don't want your stupid medal, right? Keep your medal. I'm not coming to your darn ceremony. And he made a big stink about how he was, the heck with the world. What's up, Ben?
The feeling.
Oh, I don't have the class up, do I? Now I do.
All I have to do when I'm asking is prove some guy wrong. Like
That could happen. That could happen. Like, yeah, you prove Euclid wrong, and the whole world will be your oyster, as they like to say. You know what that means?
happy.
The world is your oyster.
Uh-huh.
You're thinking of happy as a clam. World is your oyster. So an oyster is a bivalve. A bivalve is a no. A bivalve is like a clam, right? It's got two parts to it, right? Two shells, right? Bivalve. It's a bivalve. Oyster is a bivalve, and oysters make pearls. Well, they also make food too, right? People eat oyster. I love oysters, but
How dare you?
yeah. So they say the expression of the world is your oyster, meaning that the world, you are a pearl because of the world. Like the world makes you a shining example. So when the world is yours, that means you can do anything and you're going to be great at it. That sort of thing.
So Landon.
Which Landon?
The Landon from last year.
He was the guy that dropped the negatives all the time.
Well, that's small compared.
What happened to Landon?
He went to Alabama, right? He would have stayed here, but Dad's
cool.
in the Air Force. Yeah.
People.
I think he's going to try to get into the Air Force Academy, so we might see him in 3 years. I told him, I said, if you get into the Air Force, you have to tell me so that I can be there when you get there.
Air Force Academy. I'm doing Space Force Academy.
There could be one by then as well. I mean, I wouldn't doubt it. But I will say this: so if you want to be a Marine, you go to the Naval Academy. So even though the Space Force is like the Marines, they're part of the Navy. So the Space Force is part of the Air Force, but they're a separate entity of the Air Force. They're not in the Air Force necessarily. You're part of this, it comes underneath the Department of the Air Force, but it's its own separate thing, own uniforms, own ranks, that sort of thing. All right, questions on the homework? Nothing?
13. 13. Yeah.
13? Okay, let's take a look at 13.
I'm only doing it because it's proof. It's the only reason.
Okay.
I'm pretty sure I got none of this right.
I bet you got the first one right.
Yeah, Gavin. That's what I got.
What? Number one is
Gavin.
given. Yeah, she got it right. Why can I say that angle 1 is 90 degrees?
Addition. No, wait, that's wrong.
Why can I say it's 90 degrees?
Because it's a definition of a right angle.
No, I want McKinley to look at the picture and tell me why angle 1 is 90 degrees. It's got a little square on it, McKinley.
80. That's the right angle thing.
Yeah, so what if it has a little red little square on it, and next to it says the measure of that angle is equal to 90, what allows me to say that?
The right angle.
The definition of a right angle. The definition of a right angle is that it is an angle whose value is 90 degrees, or measurement is 90 degrees, and it's indicated by a little tiny square. So by definition of a definition of right angle or perpendicular lines, either one will be fine.
Or supplementary angle, right?
Well, it doesn't. If it said something, then you would say something like measure of angle 1 plus measure of angle something would equal 180.
Right,
So
yeah.
this one just says one thing. Angle 1 is 90. So definition of a right angle or definition of perpendicular lines, I'd accept either one. The book says definition of perpendicular lines. All right. 3 is horrible. I hate that they did this. They wanted you, according to the book, to write that L is parallel to N. But
yes.
ignore that. It is given, but ignore that. Pick up on number 4. So it says 2 is congruent to 1, or the measure of angle 1 is equal to measure of angle 2. That's the definition of congruence.
Is that theorem 2.8? I don't think that.
No, it's just the definition of congruence.
Okay. It's not just corresponding angles are congruent.
Because it says angle 2 is congruent to angle 1,
Wait,
or the
wait,
measure of angle 2 is equal to the measure of angle 1.
Wait, no, because you have to say that corresponding angles are congruent, right? Because it's measure of angle.
Well, that's how it starts. But then how do you say measure of angle 2 equals measure of angle 1? That's definition of.
But you never get that. You never say that measure of angle 2 is the
So you have to also say.
corresponding angles are congruent.
There you go. All right. So then, what are we going to substitute?
P is congruent to 4. I think that's wrong, but whatever.
This one is hard.
Wait, which one? 5?
Measurement.
Yeah, T is congruent to angle equals 90.
Yeah, that's what I would write.
Oh, easy.
And then either the definition, and then actually the last one has to be definition of perpendicular lines.
Wait, it has to be what?
So the last answer, number 6, it would be definition of perpendicular lines, because you're claiming that T is perpendicular to N. So why are they perpendicular? Because they form right angles, the previous statement. So that's the definition of perpendicular lines, where two lines come together and form 90 degrees.
For number 4,
Yep.
could the reason be postulate
What's postulate 10 say?
That's just corresponding angles are congruent.
Yeah, oh yeah, absolutely, absolutely. I should remember that because I taught the class this morning, and I was like, okay, you're gonna forget what postulate 10 is, and I said what it was. Okay, that's good. Ready, grade? Is that right? It was 1 through 16?
Yes.
Okay. Number 1 is angle 3, 6, and 8.
3, 6, and 8. So I only got one of those right.
Well, you're 33% good. What'd you put for number 2?
I put measurement 4, measurement 10, measurement 12, measurement 6, measurement 8, measurement 10 again.
Only one of those is right.
Measurement 4.
6.
6.
Oh, so I got half of that one right.
No, you got most of that wrong. You got your book open?
Yes.
I want you to look at angle 1. What corresponds to angle 1?
6.
6 does not correspond to
6.
angle 1.
That's 13. Right, 9. Okay, what are we on?
How about 9? Yes, 9. And then what's vertical to 9?
9 is the vertical is 7. No, not 7. That's 2. That's 2. No, 13, 14.
14.
14. Yes, I got one.
So if the only thing that we're considering is C and D are parallel, then you would have 6, 9, and 14. When you throw A and B on there, you get to those other ones that you were mentioning. All right. So now for 3, 4, 5, 6, right, we're assuming that the two angles or the two sets of lines are parallel. So in part 1 and 2, we're just saying if just A and B or just C and D. Now we're considering that A is parallel to B and C is parallel to D. So you got lots and lots and lots and lots and lots of these. So what'd you put for 3, McKinley? There's lots of answers here.
Measurement 10, measurement 12, measurement 4, measurement 6, measurement
No, it's
8.
not 6.
5?
Yes.
Okay. Measurement 8, measurement
No.
10.
No, 8.
7,
Yes.
measurement 10, but it's probably 11.
Yeah, that's right. That's right.
Measurement 12.
Yeah, and I think you said 12 twice. Book says in order 4, 5, 7, 10, 12, 13, 15. Okay?
Wait, and 12, right?
Yeah.
Okay.
All right. Number 4, I'll call these off quickly. 1, 3, 6, 8, 9, 11, 14, 16.
None of those right.
Number 5, well, if 13 is 110, then 15's also got to be 110 because the relationship between 13 and 15 are corresponding. And if 13 is 110, and then we're trying to find 3, let me find where we're going here. Hold on.
70.
3 goes with, it is 70. I'm trying to see how they got that.
Oh,
Well, 3 goes with 4, and
11
4 is congruent to 12.
All right. There's lots of different ways you can do that.
Logic.
But it is 110 and 70. The other thing is, remember what I said? I'll call the thing is that there's only ever 2 angles, right? And if everything is parallel, there's only 2 angles. So they're either 110 or 70. Now be careful. Look at me. Almost not 90 out of 100 times when you see that picture when there's 4 lines, right? Everything will be parallel, but they can be really tricky. So if you have 2 like this, sometimes, most of the time they'll put 2 like this, but sometimes they'll do something like that. Then there are lots more than just 2 angles, right? So you got to be careful with that.
Darn you, math, why do you have to make everything twice as complicated?
All right, number 6 is x and 180 minus x. Not very, very.
I did 90 minus X.
Well, it said the supplementary. On a straight line.
Up, I was.
Okay, I thought they were resting on the
Alright.
so that was
All right. 7, x is 60 and y is 61. Number 8, x is 10, y is 45. Number 9, x is 60, y is 18. Now we get to more challenging ones. 10, x is 70, y is 60. 11, x is 14, y is 9. 12, x is 55, y is 75. 12 is the hardest one. You had to really.
What was number 5? I mean, number
5?
7. My bad. 7.
X is 60, 60, and y is 61.
What is 80?
61.
10 and 45. Ben, we good?
Yes, thank you.
Okay. We just did the proof, so we got what? 14, 15, 16. All right. These are B's, so these are supposed to be harder, although I was saying 14 wasn't too bad. 14, x is 56, y is 100, and z is 25. 15, x is 70, y is 12, and z is 38. 16 was a little bit more challenging, but not too much more. I thought 12 was the hardest one. I thought 12 was way harder than 14, 15, or 16. 16, x is 30, y is 8, and z is 11.
What is 14 again?
56, 125.
Thank you.
And that's it.
question. In the story called Faithful John, why is it called Faithful John?
Because the character's name is John.
Okay.
Why is there a dinosaur about to bite my finger?
Because reasons.
What is this thing on it? Is that his ear?
No, that's his eye.
No,
What
that's
is he,
his
a-
nostril.
What do you call that? Flounder? Is he a flounder? Do
I think so.
you know what's weird about flounders? Do you know this?
No.
What's weird about flounders? You've never heard this before?
I mean, I
Ooh.
probably have.
Random trivia of the day. A flounder's type of fish, right?
Yeah.
They're flat. And they lay on the bottom, flat. So what's the problem with that?
They can't move.
They wouldn't have room for all the organs in their body.
Well, if you were to lay flat on the bottom of the ocean, what about your eyeballs? So guess where the flounder's eyeballs are?
On top of their head.
One side of their face.
Oh.
Both eyeballs are right here.
Oh.
And you want to know what's really weird? They're born with them here.
Oh.
And as they grow, the eyeball moves to the other side of their face.
Yeah, but
That's
how do they
crazy.
eat if they lay on? Do they just wait
I
for
don't
fish
actually
to
know
come
that.
back?
Flounder are very good tasting fish
So
too.
why was the guppy in Little Mermaid?
Good question. All right.
He's a
We're
baby
gonna-
flounder, that's how.
This segue here is going to require you to do some extra work on your own, but we got to look at some pictures.
Extra work. Okay.
You see?
No, I don't see, I'm sorry.
Well, let me share it with you, Ben.
Yeah.
So the eyeballs are on one side of the fish, one side of the face. So as they lay flat on the ground, this is how they camouflage themselves with the dirt. Both eyeballs are on one side. So this is how they swim, right? Like a normal fish, but both eyeballs are on one side, and they're pretty darn good at camouflaging.
Don't want to step on those things.
I don't. Rare right eye summer flounder. I don't know what that is. There we go. Look at that weird.
Oh.
See? The eyeballs move to one side. It's crazy. And the specific reason is so that they can see predators, right? If they had their eyeballs on like every other animal on one side, one eyeball goes on one side, one eyeball goes on the other side, then they would only be able to look out of one eye when they're laying flat on the ground.
Apparently a fluke is like a flounder, but with their eyes on the left side.
Ah. But the weird thing is that the eyeballs move when When do flounder eyes move? All. As they grow, one eye moves until they have both eyes on the same side of the head. Did you know? All right.
Wikipedia, yeah.
All right. Now we'll go back to math. I did run out of time, and I didn't talk about flounders in the other period. We will run out of time. You will. They'll probably be the last two theorems you'll have to write down for yourself in your book of truth. Look at me. Quiz tomorrow. If I have two lines and they don't intersect, must they be parallel?
Yes. Yes. No, they can be skewed.
Remember, they could always be skewed. So must they always be parallel?
No.
Must they never be parallel?
No.
Sometimes they're parallel if they don't intersect.
It's a 50% chance.
Right.
It's a 50% chance that I'll see things like that.
I hope it's a far less than that, because you're gonna have a messy bed. All right, here we go. Yes, and I just gave you a answer to one of the quiz questions.
Now I'm a genius.
You've been claiming that for what, 3 years?
Yes.
Almost, or 2 years and 3 months, 2 months?
Well, there's a lot of them.
And
That's actually not too much. Actually, yeah, that.
I believe there's 3 proofs you got to prove.
All right, what page is this? This is
Still fill in the blank.
I don't know. Good question.
all right. Let's see. What's on theorems in this one? There's theorem 3.6, theorem 3.7.
There's 5 theorems.
5 of them in one postulate, or 4 of them in one postulate.
Why do we have so
No,
many
5 of them in one postulate.
That's 6.
Oh,
Wow.
you're right.
It's 5 and 1
Yeah,
or
yeah,
4?
5 and 1.
5 and 1. All right. Here we go.
Totally.
So yesterday we didn't prove that lines were parallel. We showed what happens when 2 lines are parallel. Yeah.
Wait, if 2 lines are cut by a transversal and one of them is perpendicular, they'll have to be parallel.
That's one of the ones we're going to get today. All right. And it's pretty easy to prove. All right, last class we started off with construction. We started off with H is parallel to K. We get 4 statements. What are the 4 statements if they're parallel? The first statement is
one is congruent to 5.
yeah, but what's the reasoning? I mean, 1 is congruent to 5, but what's the theorem postulate? What? But what does it say? Well, why is 1 parallel or 1 congruent to 5?
Because they're corresponding angles.
So corresponding angles are congruent. What? Okay, that's one statement. What's another one?
Corresponding opposite exterior angles are congruent.
We never proved that.
But that's true.
We'll prove it today. We never proved it.
Alternate
Interior angles are congruent. That's 2.
Side interior angles are supplementary.
And the 4th one,
X,
the one that you kind of just said,
the one that I just said,
perpendicular.
line.
If 2 parallel lines are cut by a transversal and the transversal is perpendicular to 1,
Then the one is perpendicular to the other.
and I'm just going to say that's really postulate 10, which is corresponding angles, but whatever. You awake, McKinley?
Yes, I'm watching.
All right. So I don't list that 4th one about the perpendicular because it's corresponding. If this one is 90, well, that one's 90. It's corresponding.
As long as they're alternate, they're congruent.
As long as what?
As long as 2 angles are alternate, they're congruent.
What do you mean?
Because if they're alternate exterior or alternate interior, they're congruent.
What do you mean?
If they're alternate interior or alternate.
What do you mean
exterior,
if they're alternate interior? What do you mean?
If 2 angles are in this construction, alternate interior or alternate exterior.
Well, you're all in this construction. You will always have alternate interior angles.
Yeah, right.
What you won't always have is that they're congruent. You're always going to have alternate interior angles, but only sometimes are they congruent.
In this construction here, if the lines are parallel, they're always congruent.
Right. Well, that's why we have a theorem. Correct. All right, so what about this is that, is the converse true? That's what we're doing today, the converse of each one of those statements. So the converse of the statement, if we have two parallel lines cut by transversal, then corresponding angles congruent, the converse of that would be if you have two angles, or two lines cut by transversal, and corresponding angles are congruent, then they must be parallel, right? So we're not going to assume that now that H and K are parallel, we're going to prove that they're parallel. So the question is, if I can show that 1 is congruent to 5, are H and K parallel?
Yes.
Right? And the easiest way is to show you this. I'm proving a postulate here. But check it out. There's angle 1, yes? How would I make angle 1 differently? What would I have to do to line H? I would have to make it, to make 1 smaller, I'd have to move it. To make 1 bigger, I'd move it. So if you don't move it, then it's guaranteed to be parallel. It's got to be. So that's, well, we don't prove postulates, but I kind of just did. So the 3 statements we'll write them down later. Is that if corresponding angles are congruent, then the lines are parallel.
Wait, no, because if you do that, then they could be skewed and the lines.
Oh no, we're going to consider, once again, we're considering them coplanar. Everything's coplanar, right? Because none of these could be skew if they intersect, right? Well, I'm saying, and not if H is parallel to K,
right?
Which is what we're proving.
But even if they are, they're still, as long as the lines are completely straight in the same direction.
No, it doesn't work that way. Okay, the second one would be if alternate interior angles are congruent, then it turns out the lines are parallel. And lastly, if same side interior angles are supplementary, it's basically the converse of what we did. But these are the 3 ways that we're going to prove that H and K, so we're basically doing the reverse of what we did yesterday. So the first one we get is postulate 11. You won't remember 11, but it's basically, well, if you corresponding angles are congruent, then the lines are parallel.
So we can be postulate still the same.
If corresponding angles are congruent and 2 lines are cut by transversal, then H and K are parallel. We don't prove that one because, well, it's basically the logic that I just told you. If angle 1 is congruent to angle 5, then the only way that happens is if H and K are exactly the same basic line. Meaning its orientation to the transversal. Move H just a little bit, then it's not parallel to K, and therefore angle 1 is a different angle. Leave H the same way and then slide it up or down, and you're going to create the same angle. All right, so this postulate 11, like I said, it's not very memorable, the number. And we got 11 postulates now. We don't get over 20 postulates in the book, so we're almost out of postulates.
Well, we have an infinite.
But we have, it seems like an infinite amount of theorems and corollaries. I've never actually counted in the book, maybe this is the first year we do that, but I would guess that there's over 100.
There's over 100. Why do they need over 100? I can prove this all with the McKinley postulates, our theorem. What is the McKinley theorem?
All right,
The
let's not waste
McKinley
any
postulate
time.
is going to be the
All right.
death of us.
Let's go back up here. So the question is, I mean, what would this look like today for a homework question? So it looks something like this. If you want to show that 2 lines are parallel, you got to show that corresponding angles are congruent. So you tell me, are corresponding angles congruent in this shape?
Yes.
Okay, therefore line L is parallel to line M. Notice this is one of the last time you're going to see arrows, and then they stop doing it like in this one. Notice there's no more arrows. Why? Because they're lazy. I don't know. Okay, so this is the hard one right here. So this is stupid simple right here, the first one, but this one is medium, right? Not hard, it's medium. All right, it's confusing because there's just a whole lot of lines. So one way to make it easier is you declutter the image. McKinley, visually, does it look like any 2 lines there are parallel?
Yes.
Which ones? No, lines.
Oh, W-O-X and Y-I-Z.
Those are angles. Lines.
I and O.
You gotta have 2 letters.
I-Z and O-X.
Okay, so it looks like I, Z, and OX are parallel. All right, so what I'd like you to do is, if you can, declutter the image. In other words, ignore line IY, ignore line OW. If those are not there, how big is this angle?
90. 80. No, 80.
Well, how big is this angle?
80.
Therefore, you have corresponding angles are congruent. right? Therefore, they are parallel.
Yeah, the IY is not parallel.
But if we consider the other ones, now let's declutter OX and let's declutter IZ, right? If we just look at this shape, well, then these are the corresponding angles, and clearly 50 is not the same as 52. So we do get one set of parallel, even though it looks like they're certainly parallel, we only get one set of parallel lines there. So that's kind of like a medium one. So you got to be ready for, I don't know, for you to visually make sense of a somewhat complicated shape there. We good? And oh, by the way, how many ways can we prove that two lines are parallel right now?
51.
Just one, postulate 11. Well, we're soon to have some more skills. So let's do a proof. We're trying to prove that if alternate interior angles are congruent, then the two lines are parallel. This should be a proof that all of you can handle, right? So don't yell any answers. We're going to let everyone think. So we start with the given. We're trying to get to where the K is parallel to N. So I'll say it again. How many ways do we have right now to show that two lines are parallel?
Postulate 11.
So what has to be the step right before this?
K equals N.
2 and 3 are
Yeah, but what would be the statement? That would be the reason.
2 and 3 are vertical. So that you
No. The statement before this one right here. The only way we show that two lines are parallel is by what?
0 and 3 4.
Hold on.
Postulate 10.
Postulate 11.
11. Yeah.
So what does postulate 11 say?
The two lines are cut by a transverse arrow and their corresponding angles are congruent with the line.
So we need to show that the corresponding, which ones are corresponding angles here?
3 and 1.
So this statement's going to say what? The one right before the very last one. No, that's the reason. That's the step. Angle 1 is congruent to angle 3, right? You follow the logic? And therefore the reason is that by postulate 11, or that, you know, if you want to write out the longer form of it. Okay. So now just hold on. I said everyone should be able to do this one. So even if you don't know what the next statement is, look at the picture. How many things can you tell me, Anna, about the picture that we haven't already said? We can't say that yet because we haven't proven it yet. I'm looking at the picture. I'm trying to say anything. Okay, we can say that they're alternate interior angles. It doesn't get us anywhere. What else can you say? And by the way, that was part of the given, was that 1 is congruent to 2, and we've already said it. Okay, we can name them. Okay, 1 and 2 are by name an alternate interior angle. Is there anything else up there that you can say? Look at the picture. Okay, so therefore, what can we say? Okay, so let's say that 2 is congruent to 3. Why? Because they're vertical angles. McKinley, you follow? Stop. Let everyone think. Okay, I'm going to walk you through it. 1 is congruent to 2. 2 is congruent to 3. Therefore, 1 is congruent to 3. Why? Right, if you want to say transitive, this is the classic case of transitive, but you can also say substitution. Oh, and by the way, we're done. That's it. That's the whole proof. So we just proved that if alternate interior angles are congruent, then the two lines must be parallel. This is theorem whatever 3, 5. Okay, 3, 5. It's a converse to 3, 2. So therefore, it makes it biconditional. The book chooses not to write it as a biconditional, but we could. Later on in the book, when there is a biconditional, they will write biconditionals. But I guess starting off, they don't want to scare you with a biconditional. So if two lines cut by transversal are parallel if and only if the lines, like, let me see.
If 2 lines are cut by transversal and alternate interior angles are congruent.
You have to use the word.
No, if 2
Alternate
lines are-
interiors are congruent if and only if 2 lines cut by transversal are parallel. There we go. Okay, and that would be the opposite of what I said, or the converse.
Wait, can you have a converse to a biconditional?
You can, but we wouldn't call it a converse because it's biconditional. So by definition, a biconditional goes both ways. All right, well, let's see, that's what, 2. Ben said we had 5 of these. 6? Uh-oh. We got 4 left.
Actually, a 6.
Okay, so we got 4 left. All right, what's that question going to look like? These are both easy questions. All right. Number 4, McKinley, which sides are parallel?
EG and MA,
Why?
because they're the same exact length.
Okay, so I'm going to declutter the picture. You said EG, that would be this one. And you said A, is it A? AM? That one. Well, they're cut like this. So for these to be congruent, either alternate interior angles must be congruent or corresponding angles. Do we have any corresponding angles in the picture?
No. 48 and
So therefore, this one and this one must be the same. Well, this one is how big?
44.
And this one is, oh, it's not listed.
Or you
So,
could use supplementary angles.
so are the, we're not there yet. We're not there yet. So are these two here, GE and AM parallel? No. So maybe if we declutter this one, same picture, now I've got to show that that one is the same as that one. Is that true?
Yes.
Okay, so they're parallel. So which ones are parallel?
48, 48, right? No, 44.
And sides or lines,
GA, EM.
GA and EM.
And GE and AM aren't, right?
They are not.
They're not.
Well, we just don't know. I mean, there's no right angle here, so we don't even know what it
Supplementary
is.
angles by GE and AM.
I'll just say we don't know because this one isn't listed. Plus, you don't even know how many degrees are inside of it. You can't tell.
See, 44 plus 48, 90 plus.
You can't tell. Not on this picture.
You can.
We don't know how big that one is.
I know, that's not what I'm saying. I'm saying I'm comparing GEM to AME. And they have to be supplementary.
Why do they have to be supplementary?
Because let's cut by a transversal.
Oh, no. This is what we just proved, right?
Right.
So which one are supplementary?
So what I'm saying is if GE and AM are cut by the transversal of EM, then the supplementary angles of GEM plus AME.
You got to back up. Say it again.
Okay. If so, GE and AM are cut by the transversal of EM.
Okay, let me. So you're saying this and this are cut by that. Okay.
Cut by EM.
Okay. All right. I got you.
Then 90 plus 48 plus 44 must be.
Well, what's 48 and 44?
Is 92.
So they're not parallel.
So they're not parallel, which is what I was saying earlier.
Oh,
So
well,
that's
we
how
already proved that from the other one. Why were we going back to back?
No, you said we couldn't prove that.
You know, I was not hearing what you were saying. I was saying that we could not prove that. I mean, how big that angle is. I mean, I don't know how big it is. I also don't know how big that angle is. Right. But if I did, then I'm with you. But you're right about the fact that we can't prove that the other ones are not parallel. All right, let's go to this one. Anything parallel? Anna says, or Alex said, no, nothing's parallel.
Yeah, it is.
Which ones are parallel?
44, 46, and 44. They're on the same exact side, or 46 and 44.
In order to show they're parallel, we got to show things are congruent.
LA,
Is anything congruent?
yes, LA and TS are congruent to each other.
Now you're talking sides, we're talking angles.
Oh, angle, well,
Which angles are congruent? Are there any congruent angles here?
no, yes.
Sure, 46 and 46.
Yeah,
Are they alternate interior to each
yes,
other?
Yes.
What does alternate interior mean?
Oh,
You swap sides. This is on the top, this is on the top. If they're alternate interior, we're looking at this angle and this angle, or this angle and this angle. So none of the alternate interior angles are the same, therefore, there's no parallel sides here. None. Jack wants us to go to these two quickly. We will get there, but we're not there yet. Oh, by the way, this one does have parallel sides. We just don't know it yet because we need the next one.
Oh yeah. Wait.
Then we'll be able to show that things are parallel. Oh, by the way, there are parallel sides here. All right, top and bottom parallel. But we don't know it yet because we don't have that one. Let's get that one. All right, this is Theorem 3.6. This is tonight for homework. And it says the following. If same side interior angles are supplementary, then the two lines are parallel. So if same side interior angles are supplementary, then the two lines are parallel to each other. So if I were to show you that picture now, that second one, we would be able to conclude that two of the sides were parallel. Now, how many arrows do we have in our quiver to prove two lines are parallel?
Too much.
I mean, they're taking the arrows off the line.
Two.
No, I was making a metaphor. We have three. We can either show that corresponding angles are congruent, or we can show that alternate interior angles, or now we can show that same side interior angles are supplementary. If we show any one of those, we can prove that the two lines are parallel. We get a fourth arrow in our quiver, and that's the same thing as yesterday. What's that one going to say? What was the fourth statement we had about?
If transverses cut by
Okay, so we're going to get the converse of that. If two lines
that's the exact same thing. If
are
the
perpendicular to a transversal, then the two lines are parallel to each other. You got to put one caveat to that, and that is that the two lines have to be coplanar, because we can't get this configuration. I need a third. Hold that vertical. So you can get this. Hold that vertical. So you can get this configuration like this, right? So even though the yellow one is perpendicular to both of these, right? These could be skewed. But if I force these two to be coplanar, this is the configuration they're talking
Why
about.
are we not saying they're all in our theorem?
Well, we say that two, remember all the other ones start off with the two lines are parallel. All right. And remember, that's what we are proving. We're proving that two lines are parallel. Okay. All right. So what would the previous question look like? Okay. Hey, what's 118 and 62?
Is 180.
So which are parallel?
KD and CE.
Yeah, KD.
No,
So what?
DE and KC.
DE and KC, right? And we can't say anything about these two because, oh wait, we can. What's 118 and 64?
It's at 182.
Not at 180, right? Right. So the other ones are not parallel. All right, and then we get to this one right here. So if in a plane, notice what they got to put that one caveat. In a plane, if two lines are perpendicular to the same line, then the lines are parallel. So this is the converse to 3/4.
Wait. No, that's it. Yeah, you're right. It is.
Don't get hung up on the numbers. You'll drive yourself batty.
What if I want to drive myself insane?
Well, I think you've already made some great progress towards that, Kelly. Golden goose. All right, we good? All right. So far, show two lines are parallel. We either show the corresponding angles are congruent, alternate interior angles are congruent, same side interior angles are supplementary, or in a plane, if two lines are perpendicular to the same transversal, then the lines have to be parallel.
Well, you have to say it's like all of them.
It would be helpful, sure. It would be, right? All right. I promised you today I would prove that exterior angles are congruent. You guys are going to do that for me real quick. Let's see if we can do the proof. The book just says, and oh, by the way, alternate exterior angles are congruent. Let's see if we can prove that. We're just going to write statements. We're not going to write any reasons. So let's just call that angle 1 and angle 2. I'm trying to prove that angle 1 is congruent to angle 2.
Okay, then what, you're gonna have to label.
What do you want me to label? And there's different ways of doing the proof.
You're gonna label 3, which is the vertical 1.
Okay. This is one way of doing it.
And then you say 1 is vertical to 3, so 1 is congruent to 3. And then 3 is then congruent to 2 because corresponding angles are congruent.
Okay.
And then,
And then transit.
yeah, and then transit.
Or substitution. Okay. So that's how we'll get to that. Now, what about the converse? So if this is congruent to this, can you show me that the two lines parallel?
Yeah.
All right. How would you do that?
Same way,
Well, let's see if that works. What would be your first statement?
to label 3.
Okay. Label 3.
And then we do 1 is congruent to 3.
So angle 1 is congruent to angle 3. Okay. Now
And
what?
then angle 3 is congruent to angle 2.
Hold on, I gotta write the first one. So let's see.
Well, no,
Angle
no,
1
never mind.
is
That
congruent to angle 2. Okay. That's the given. This is vertical angles. Now what?
That means 2 and then you do.
No, I don't have to do that. I don't have to do that.
No, I like that. That's fine.
Well, 1 and 2 are already congruent.
Continue with your
And then-
statement.
Oh, and then you just say, if alternate interior angles are,
Well, how about you just do a quick substitution, like you just did before?
and then just do 1 is congruent to 2. Well, that's where we start off with.
No. How about 2 is congruent to 3?
Right, we already proved that.
No. We're doing the converse. We're
Oh.
trying to show that two lines are parallel,
Then
right? I was not able to say that 1 was 3 because the two lines are parallel. It doesn't matter because they're
Then
vertical.
2 is congruent to 3, and then you can use corresponding angles of the 3.
If corresponding angles are congruent and two lines are cut by transversal, then the two lines are parallel. Okay, there we go. So you may use that. We don't even write it down because it's not a named theorem, but you may use it because we prove both biconditional. So both ways. So exterior angles are congruent. We just did a quick proof on. Cool. We could also do same side exterior angles or supplementary as well too, but I'm choosing not to do that. All right. Once again, a complicated one. So the technique is to declutter it to make it a little bit easier. Which ones look parallel?
Look, I know which ones are.
Which one?
I, H, and N, P are
H and the T's. Okay, so I'll declutter that, and I'll declutter that. So how big is this angle?
82. No, 84.
How big is this angle?
84.
All right, those are congruent. What about the other ones?
Nope.
61, 62. Not parallel. Okay. The declutter thing, what I just did right there is I literally shaded out. Sometimes that's not very effective because it's a really complicated picture. Sometimes you got to redraw it. All right. Last class, some more examples. Just remember, those are the three main techniques we have to, once we know that two lines are parallel. I'm not sure why they threw this example in. This would have been better suited for yesterday. But here's the shape. We're given that this line, AC, is parallel to DF, and that AE is parallel to BF. So we're given that.
Yeah, you do.
All right, McKinley, this one's yours.
2y minus 5 equals x plus 50.
2y minus 5. Keep talking.
Equals, so then you just have to.
Why are these two equal? Don't say anything. Why are these two equal?
Because they're on the same line. Because of.
Turn your head to the left. So I got two parallel lines cut by this transversal.
Same by the parallel lines.
What are the names of these two angles? Don't tell me x, y, but the names of them. Are they corresponding? Are they alternate interior? Are they same side interior? Are they?
Same sided.
What do we know about same side interior?
They're equal.
They're not equal.
Congruent.
They're not congruent. Unless they're perpendicular.
But they are perpendicular.
They're not perpendicular. Doesn't say anything about being perpendicular. What do we know about same side interior angles? It might be quicker to flip your book.
What? Oh, do you want me to say?
No, I need him to do this.
Interior angles, two interior angles on the same side of the transversal.
And what do we know about them?
They're the exact same.
No, they're not, unless they're perpendicular.
I don't know.
They're supplementary.
Yeah.
So what statement could I make now that you know that they're supplementary to each other?
Oh, they're plus 180. They're both plus 180 or minus.
Say it a little bit better. I know you're thinking the right thing.
180 minus 2y minus 5 plus x. Plus
You're confusing yourself. What does it mean to be supplementary?
that they're equal 180. So they
Okay,
both
but what does that
equal-
mean?
They add together to equal 180.
That's what it means. Now write that statement.
Okay.
No, I mean, just tell me what to write.
Oh, 180 equals 2y minus 5 plus x plus 50.
Boom. Now look at these two angles. What can you tell me?
They're congruent
Why?
because they're the exact.
They're not
They're
same side.
parallel. They're parallel.
Angles can't be
They're
parallel.
not parallel. They're on the same exact side.
They're not on the same side. One's on the left, one's on the right.
I don't know how to say, but the
Remember, we have four statements. Corresponding, same side interior, perpendicular, or that middle one, which you're not saying.
middle one.
Alternate interior angles are congruent. So if they're congruent, what could I write?
They equal 180.
No,
They
unless they're
equal,
perpendicular.
they equal 90.
No.
They're equal to each other.
So what can I write?
X plus 50 is equal to 3x plus 20.
You see the two equations, and now you know why we did system of equations the other day? You got two equations. Let's solve one. Which one you want to solve, the top one or the bottom one?
Top one.
Because it's easier because it has two variables, yes?
Yes.
How many variables does the bottom one have?
1.
So isn't it easier to solve for one variable?
Yes.
Let's solve the bottom one. Solve it. What do we do?
2x equals 30.
Therefore, x equals.
Says
You did two steps in your head like that, and you're stuck on 2x equals 30. Thank you. All right. Now, what do we do with that?
put it back into an equation.
To the first one. Okay, so I'm plugging it in for the right there. Keep going.
20, 25, 250.
What?
Yeah, 15. No, wait, plus. Oh, plus here. 65 minus 65. That's 60. 2y plus 60. 120. Some number that's smaller than that.
Very good.
60.
You are a math genius. Very good. All right. Yes?
Yes.
Medium, easy, medium, hard.
Decent.
Yeah, it's somewhere between easy and medium, right? But this one wasn't too challenging. All right. Now, I would not have written this section like this. These are important. I would have put this in a separate section, but our book just like switches gears, and we don't talk about, well, we are talking about parallel lines, but not that construction. So we got two left, and here they are. So this is Theorem 3.8, also for homework. So here it is. You got a line K, and what do you got here? Okay. So how many lines can you draw through P that are parallel to K?
1.
And that's what it says. Through a point that is not on the line, there is exactly one line parallel to the given line. And you guys get to play with that tonight. So there's the line right there. You don't have to draw that second one.
So it would be also the same way if you had to be on the line perpendicular.
That will be Theorem 3.9.
Sir, we only have to prove theorems 3.6 and 3.7 for homework.
Oh, you want to prove this one real quick? All right, let's do it. Here we go. Well, what would happen if there was a second line that went through P that was parallel to K?
It would intersect.
What's the problem with this shape?
It intersects.
Well, it intersects K, clearly, right? I don't care how close you put it to N, but if it's a different line, eventually it's going to intersect K. There, I proved it for you. All right, we call that a hand wave proof if I do it like that. Last one you need to copy down. It's what Jack said, which is through a point not on a line, there is only one line that is perpendicular.
Wait, through a point, it could be on the line though.
It says not on a line.
But it could be on the line.
Well, not in this case. We're saying it's not on the line. Through a point not on the line, we will actually get the other part of that statement of what you're trying to make is through any point on a line, how many lines are perpendicular that go through that point one, right? But they say that for a different. We do that when we start talking about triangles and proof by contradiction. Oh, you're going to love those. Okay. There's one last one, 310. You guys are going to, tonight for homework, you're going to open the book, put it in your book of truth. It's an easy one.
Wingardium Leviosa.
No, it's Leviosa. You don't get it?
Yeah, I get it. It was small.
All right, Ben, any questions?
No. Actually,
All right.
yes.
Just remember that email sent you the video and the homework. Unless you copied it down, are not going to get posted until 8 tonight. So if you want to look at the homework, I'll leave it on this so that you can see
Oh, no
again.
worry. I copied down the homework.
Sounds good. We'll catch you tomorrow then, Ben.
Okay. See you later.
Later.